Power of a test. The power of a test is the probability of rejecting the null when it is indeed false. If I could just pause there for a quick second. Here's the observation that I'm making so far. This power of a test exercise is a theoretical exercise, and here's why. We don't know what the true population value is, so there's no way of us knowing if the null is true or false. So how can we even calculate the probability of rejecting the null when we don't know what the true population value is? And that's why I refer to this as more of a theoretical exercise, because we're assuming that we do know what the true population value is. So as a result, the power of a test is the complement of the probability of type 2 error. So let's do an illustration. Suppose that a light bulb manufacturing company believes that its bulbs should last for 600 hours. So this is its null hypothesis. And we have to appreciate the situation here. This light bulb company is not going to test all their light bulbs, because then they wouldn't have any light bulbs left to sell. So what they're going to do is they're going to draw a sample, and based on the sample findings, it's either going to support their null statement, which is right here, or it's going to reject it. And there it is. To test this hypothesis, the firm will draw a sample to see whether the sample supports or refutes the hypothesis. So the following are the scenarios which may unfold in this illustration. The first outcome is the following. The null is true, but the sample ends up rejecting it. So this is the type 1 error, and we saw this in the previous LOS module. And the probability of a type 1 error is equal to the level of significance. So if the level of significance is 5%, there's a 5% probability that will reject the null. But again, remember the overriding issue here. We don't know what the true population value is. And here you are, you're rejecting it when you don't even know what the true value is. So there's a chance you're making an error. And that error, the probability of making that error in this case is 5%. The second outcome is as follows. The null is true and the sample supports it. Well, this isn't an error at all. This ended up being a correct choice. So this would be the correct choice, and its probability would be equal to 1 minus the level of significance. So using that same 5% level of significance, there's a 95% probability, i.e. confidence, that the true null would be accepted. Now the third scenario is as follows. The null is false, but you accept it. So clearly that's an error, and as we saw in the previous module, this would be a type 2 error. However, as we indicated again in the previous module, we can't quantify the probability of type 2 error because we have no way of knowing if the null is false in the first place. Therefore, we'll refer to this unknown probability as beta. And if I can just elaborate a little bit here, ladies and gentlemen, the fact that the null is false. First of all, again, we don't know what the true population value is. So how do we know for a fact that the null statement is false in the first place, right? And that's why I refer to this as a theoretical exercise. So let's assume that the probability, and that's why we say that it's an unknown probability. So let's identify that as equal to beta, because again, if you don't know what the true population value is, we don't know if the null statement is true or false. So the fourth outcome is that the null is false and the sample ends up rejecting it. So therefore, the probability of this outcome is referred to as the power of the test, and it's equal to 1 minus beta. So for example, if there's a 65% probability of accepting the null when it's false, in other words, the beta is 0.65, then there would be a 35% probability of rejecting the null when it is indeed false. So therefore, the power of the test is the complement of beta. So there it is, 1 minus the beta. That gives us that 35% probability. And I just want to reinforce the big picture behind outcome 3 and outcome 4. You could see that they're both reaching the conclusion that the null is false. And again, ladies and gentlemen, that we don't know the population value, so we have no way of knowing if the null statement is true or false. So if you say that there's a 65% probability of accepting it, which would be an error, then there would be a 35% probability of rejecting it. And the power of the test is referring to this outcome where the null is indeed false and we end up rejecting it.